Hello, my fellow mathletes, and welcome back. Root Beer here with question number 6 on our 2011 Euclid paper. So, A part. Serge likes to paddle his raft down the Speed River from point A to point B. The speed of the current in the river is always the same. When Serge paddles, he always paddles at the same constant speed. So we got same speeds, nothing's variable, nothing's changing. On days when he paddles with the current, it takes him 18 minutes to get from A to B. When he does not paddle, the current carries him from A to B in 30 minutes. If there were no current, how long would it take for him to paddle from A to B? Okay, so we want to know how long it would take him to paddle from A to B. Well, it might be a good idea to find the distance between A and B and how fast he paddles, because remember, he paddles at the same constant speed. Right? So those are the things we might think to try and find. So we might say something like, okay, we could imagine sort of a speed river. We've got point A here, point B here. We'll call the distance between them D. Okay? Now, the river has a particular speed. We'll call that maybe speed R. So the river goes R kilometers per hour. Well, actually, no. Let's say they gave us minutes. So I'm actually probably going to use meters per minute. We don't know whether or not we should be using kilometers or meters. It doesn't particularly matter because they didn't tell us meters or kilometers or anything like that. But they did say minutes a couple times. Okay. So the river's got a certain speed. We'll say Serge has a certain speed. We'll call it S. So Serge is at S meters per minute. Okay. Now, we're told that it takes 18 minutes, so that's the time, 18 minutes to go this particular distance D, which I guess we'll have D meters, if he paddles with the current. So if he's in his little boat or whatever it is, he's moving at S meters per minute. The river is also pushing him at S meters, so in total, he's going R plus S meters per minute. So 18 is D divided by R plus S. Okay. We also know 30 minutes is how long it would take if he just lets the river carry him, I think it was. When he does not paddle, so he's not adding his own speed, it's just the river's speed. So D over R meters per minute gives me 30 minutes. Okay, so what can we do? We can actually sort of multiply by R plus S on both sides, divide by 18. We can rearrange this to get R plus S is D over 18, and this equation over here can be rearranged to R is D over 30. So instead of solving for time, we're actually solving for our speed. Okay, so R plus S is D over 18, R is D over 30. Okay, so we have to subtract these two. Oops, need another one. This one's 18. So subtract R by itself is D over 30. So the R's will go away. You'll be left with S is, so you get a common denominator of 90. So you'll get 2D over 90. Yeah, because this is 3D over 90, and this is 5D over 90. So that's really the same as D over 45. So we know that his speed is the distance between A and B over 45 minutes. Now we can do the same trick. When we rearranged these expressions here, we solved for the time. We could actually rearrange this and say, okay, 45 minutes must be the distance he wants to travel, A to B, divided by the speed of just him paddling with no current. And that's exactly what we want. If there were no current, how long would it take him? 45 minutes. And there we go. That's all there is to it. So we didn't actually solve for the distance. Didn't actually matter if it was meters or kilometers. We just sort of used it as a placeholder, this nice common value D. We got our answer, 45. And it is just a light bulb, so you don't actually have to explain that or do any of the calculations or show your work or anything like that. Okay, B. Square OPQR has vertices. O is at the origin, P is at 0, 8, 8, 8, 8, 0. Okay, I'm just going to go ahead and draw a picture of this. So they've got the word parabola in there, so we might have to draw a parabola. So O, P, Q, R, I think is the order. P is at 0, 8. No, I got it wrong. We go up to P, we go right to R. The parabola with equation y equals a times x minus 2 x minus 6 intersects the sides of the square at points k, l, m, and n. Determine all the values of a for which the area of trapezoid KLMN is 36. Okay. So I would probably start by saying the roots of the parabola are 2 and 6, because they do give us the equation. Not that hard to pick out the roots here. Now, this means, so the parabolas are always sort of symmetric about the middle axis. So if I were to draw sort of a parabola in here, I can draw a better parabola, I swear. We'll try something like this. It's not bad. But parabolas are always symmetric about this nice little axis, or this vertical axis here. So we could say something like, so the axis is x equals 4. The parabola is symmetric about this axis. Now, in my drawing here, I've got the parabola facing up, so A would have to be positive. Now, they said it intersects the sides of square OPQR, but I mean, this is one picture. Surely, if I wanted a downward-facing parabola, I could do something like this, couldn't I? And then I have my other points up here. That wouldn't necessarily be bad. Okay, so it looks like we'll have two cases. This is A being down, negative. This would be A being positive. Okay, so, but either way, we can see 2, 0 and 6, 0 are 2 of the 4 points. On KLMN. I'm just going to call this one K, this one L. Okay, so for example, over here we'd have M and N. Okay. But because we're symmetric about the x equals 4 axis, the height of N is going to be the height of M, because we've got the x-coordinate of 8 here, the x-coordinate of 0 here. Those are both the same distance away from this axis, so by symmetry, we're going to have the same sort of height. Call it y. Okay? So what does this really tell me? Well, if I look at KLMN, KL is parallel to the x-axis, because, hey, it's part of the x-axis, but MN is also going to be. Okay? And the same thing holds for this picture here. Okay? So we can see, I'm actually gonna get rid of this. I'll do this case separately in a moment. So if A is positive, we'll say M and N are on, what was it, R, Q, and PO, respectively. They are both, let's say, distance 4 from the from x equals 4, the axis. So by symmetry, have the same height. So you can say something like let m be at 8y and n be at 0y. So then I'll say then mn is parallel to KL. KLMN is a trapezoid. So this is really nice because there's a formula for the area of a trapezoid. And we haven't used, oops. There we go. I can draw a little better than that. No, I can't. I just want these to roughly be the same height. How is that so hard for me? Okay, anyway, trapezoid here. So how do you find the area of a trapezoid? Well, you take the base, which is going to be 8, and then the top, the other parallel side, which, well, we know we're going between 2 and 6, so it's going to be 4. And then we need this distance, which is going to be the y value that we've got here. And we know 30 is the area KLMN. So it's 1/2 of the height, so y, and then the sum of the top and the bottom, the two parallel sides. So this is 6y, and so I conclude that y has to be 5. Okay. And what did they want exactly? They determined all values for a. So now that I know that this y value is 5 when I plug in, say, 0, I should be able to work out my a. So y is 5, and this is a times 0 minus 2, 0 minus 6. Well, that's just going to be 12a. So a is 5 over 12. So that's one case. That's if a is positive. This is the only way it's going to work out. So now we ask, what if a is negative? Well, the picture we get is a little different because the parabola is facing down. Now we still are stuck with these roots. Okay, so as we get higher, we get closer to this axis here. So our other points, we'll still call them. So we had K and L here. Call these ones M and N. So then M and N are both on what is that? PQ. We'll say M is at A8 and N is at B8. Actually, no, the question already has an A. Let's just use little m and little n. That works out. Okay. So now by symmetry, four is the average of m and n, because it's got the x equals 4 axis has to sit between the two of them. So 4 is m plus n over 2. Okay. Is there anything else we can say? Not that I can see right away. But that's okay. So once again, we've got ourselves a trapezoid. This time we know the height is 8. This base here is 4. I don't know the distance between these two MNs, so maybe we call that D. I don't know. Okay. So we'll say the distance between M and N. Well, actually, we can just say the length MN. Say let D equal length mn. This is going to be m minus n, and I do know the m is supposed to be bigger just based on where I put it in the picture. Okay, well then 30, which again 30 is, oh sorry, the area is 36. I'm glad I double checked that. So quickly, let's go back and fix this last one. 36 is the area, which means y will be 6. So we get 6 here, still 12a. Now it's 6 over 12, or 1/2. A being 1/2. Okay, that's fine. 36, not 30, is 1/2. The height of 8, and then d plus that base of 4 that we already have. So this is 4d plus 4. Divide both sides by 4. 9 is d plus 4. So d should be 5. So that's the distance, the difference, m minus n is 5. Now, that doesn't really work. Because you're saying these m and n are further apart than the k and the l. So that's going to lead to a problem. Oh, I suppose... Oh, I forgot about this. We could have had the... I suppose this isn't the right picture. We could have had a really, really skinny positive one, couldn't we? Yeah. So you could have that. I didn't really go through the possibilities properly. So you could have... Parabola's got to be symmetric about y equals, or x equals 4. So if n is on this side, m has to be on the other side by symmetry, but they could have intersected up here at the top. So those are the two cases. You can't really do a being less than 0, which is fine. So mn is 5, m plus n is 8, because 4 is their average. And so 2m will be 13. So m is 13 over 2, and so n would be 3 over 2. Okay, that seems perfectly fine. And then we just plug in. So 8, the y value, is going to be a 3 over 2 minus 2, 3 over 2 minus 6. So 8 is a times negative 1/2 times negative 9/2. So 9/4 a, so multiply both sides by 4, divide by 9. A is 32 over 9, and that is quite the steep parabola. But those are the only ways for the parabola to intersect the square. So I'm satisfied with our answers. So we could probably summarize. A is 1/2, or 32 over 9. I want to double check the 32 over 9 just to make absolute certain, just because, well, I screwed up the 30 and the 36 already once. So I have 32 over 9, and then what was our other point? 13 over 2. That'll be 32 over 9, 9 over 2, 1 over 2. So that'll be 32 over 9, 9 over 4, and that will leave me with the 8 that I want. Okay, I'm convinced 32 over 9 it is. Okay, so that was question 6. That was our B part. We did write our solution. We had our parabola intersecting square cases. And that's it. So up next is going to be question number 7. I hope to see you for that shortly.